Good morning, students. Today we are here, both class 4 and class 5. Both classes I have called here together because I thought that a very important chapter in your science books, solids, liquids and gases. This chapter is in both class 4th and class 5th. In class 4 a little less and a little more in class 5th. But I thought since during this lockdown period your studies, the usual hours of study has become a little less. So why not study a little more and call you together and teach you together so that both of you benefit from it at the same time and a little more than usual what happened if you were in your own classes. So, solids, liquids and gases. These terms and about these terms you have to learn both in class 4th and 5th. In the upper classes also, we are giving you a introduction to this topic. What happens is that, you know about matter. Everything around us is made up of matter. Matter has two qualities. What is matter? Matter is something that has mass and also that has volume. What I mean by mass and volume, matter must be made up of something. It has some material inside it. It must have some weight. And the second point is that it must occupy some space. It needs some space to remain. So, matter is something that has mass, that has some material inside it, and has some volume because it occupies some space. Whatever we see around us, all are matter. What we can feel, that is also matter because you see, ear we cannot see, but we can feel. If ear is matter, you can prove it that ear has mass and ear has volume. Now suppose you take a football without ear inside it, a deflated football like this, right? Let us assume this is a deflated without ear football, and you pump air in it and it becomes round. So how does it change shape? A deflated things become more round because we have pushed air inside it. So air must have some mass and air must have occupied some space. Otherwise, how this football would have changed shape? And also, if we have take weight of the footballs before putting air inside and after putting air inside, we would have found that in this condition, deflated football would have less weight than when it is inflated. So air must have some weight also. So air has mass, air has volume, so air is also matter. In the same way, everything around us is matter. And all these matters, they exist in essentially three states. But before that, look at the slide about what is matter.
Matter is something that has mass and also volume. It must contain some material, has some weight, and also it must occupy some space. Even air, which we cannot see, it also is matter and it has mass and also occupies some space, volume. Because you see these footballs, one has air inside it, the other does not have. So the volume and the weight both changes when air is inside the football. That proves air is also matter, it also has mass and volume. Now matter can exist in three states. I will explain it very soon, but as well you can learn it. Matter can exist in three states: solid state, liquid state and gaseous states. And also learn at this point the three states of matter are interchangeable. One state to another state, it can be transformed. On adding heat, solids become liquids. And if you heat it further, the liquids become gases. The opposite process happens when we cool down a gas, it becomes liquid, and on further cooling down, it becomes a solid. Here you see the continuous process has been shown in a picture, how ice, a solid, on heating it melts to become water, and then it becomes a gas, water vapor, and then it cools down and it condenses and it becomes water again, and finally on freezing, putting it into the refrigerator, it becomes ice again. The same picture will show you how the states of matter on heating and on cooling down are interchangeable.
So now that we know matter, let us talk about state. State means in which condition anything is there. Suppose this one, this is a solid. Suppose we had a glass of water. You see, two are in different states. The water inside the glass is liquid, but the glass itself is solid. In the same way, if you push air into a balloon, the balloon, rubber balloon, that is solid, but the air inside it, that is gaseous. So any matter, it can exist in three states of matter. Three states of matter. First is solid, second is liquid, and the third is gas. So what are the three states of matter? Matter can exist in solid state like ice, in liquid states like water, the same matter. Ice and water are not defined, only they are different in state. One is solid and one is liquid. And if you heat that water, it will become steam. It still is water, but it has changed its shape into gas. So now we will go into a little detail about what if the same matter, they go into different states and how they change the state of that matter. To know that, we must know how matter is made of, what it is made of. You will learn a little more in the other classes about this, but let us learn at this stage that every matter, like our body, you know, are made up of very tiny cells. All the matters in this world are made up of very small particles. Very small, so small that you even cannot see them through a very strong microscope. These very small particles which make matter, different kinds of substances, are called either atoms or molecules. Both are the very small particles. You will learn about the details of these things in upper classes. Let us call them particles, molecules for our sake of convenience. it will become easier to understand. Now, every matter is made up of a certain number of, say, molecules, very small particles. These molecules are arranged in a certain way. There must be a pattern how the molecules are there. These molecules have some force between them so that they keep together. So any molecule, any matter made up of molecules, they have two properties, two qualities. Number one, that these molecules must have some force of attraction. They must be attracted to each other. Otherwise, the matter would not be together. Molecules will just fly away. And the second is that there must be some space between the molecules. These 2 points you keep in mind. I have prepared a slide so that you can memorize this thing before going into the details of this what I just said.
Matter is made up of very small particles. We call them molecules for the time being. In the upper classes you will know what are molecules, what are atoms. But now let us say the 2 points you should keep in mind. That the molecules are arranged and the force of attraction between the molecules. This is called intermolecular force of attraction. And the space between the molecule, that is intermolecular space. The molecules must have some force of attraction between them, and there must also be some space between the molecules, and the relation between the intermolecular space and intermolecular force are opposite. Less the intermolecular space, more the intermolecular force of attraction.
So these 3 points you have taken in, I will explain them now. Matter is made up of very tiny particles, smallest in size. These particles are attracted to each other, otherwise this paint, made up of tiny particles. Unless these particles are attracted and keep to each other, it would not have been a pain. All the molecules and atoms would be flying away from each other. So they must be attracted to each other, these particles. But these particles also have some space between them. So now let us look at, say, a block of ice, say 1 kg ice. What happens is that in this block of ice, say it is 1 kg ice I have taken, all the molecules, that is the water molecule, because it is essentially water, you know that. These molecules are very tightly packed. Very tightly packed that there is almost no space between them. Now why they are so tightly packed that they have no space between them? Can you answer that? It is obvious that the molecules of water, which we call H2O, you can as well learn it. The molecules of H2O, when it is in solid state, in the form of ice, the molecules are attracted to each other so much that they have no space between them. They are tightly packed. They are so much attracted to each other. The force of attraction is so much in the solid form, in the ice form, that they have no space between them. So, when something is in solid form, its particles in it, atoms or molecules, they must be so much attracted to each other that there will be very least space between them. So one thing you understand from here, that the more the force of attraction, the more forcefully these particles are attracted to each other, the less space between them. They have an opposite relation. If you increase the force of attraction, the space decreases. And if you decrease the force of attraction, make it less, they are less attracted to each other by some method. The space between them will increase. And that is what we will do here. Suppose now we put an fire underneath this ice block. Till now this ice block did not need a container, a vessel to keep it, because it would have been kept anywhere and it will be intact instead. But if you want to put it on fire, you must have some vessel, because you know, you have seen what will happen very soon. Very soon it will happen like this. Now what happens? Fire, it is giving heat to the ice. Now this heat is an energy. It gives you energy. You know, energy is something that gives you the force to do work. And this energy fan is giving heat to these particles which are very closely packed. Every particle gets some part of that heat. Every particle gets a very small fraction of the total heat given by the fire. So they are becoming a little more energetic. They want to move away and they try to break away from each other, because now this extra energy, it is breaking down the force of attraction that binded them together. What happens then? Now the same molecules, they try to move away from each other. And very soon, when this 1 kg ice will turn into 1 kg of water, that is liquid, what happened? What change had happened? The same number of molecules are there, but now you definitely need a container to keep the same number of molecules at one place. Otherwise it will flow away. The same number of molecules, when it was ice, you did not need a vessel to keep it in. But now it has turned into liquid. Why? Because the particles have been given more energy and now they are breaking apart from each other. The less force of attraction, less attractive, so the space between them are increasing. Now unless you put them in a vessel, they will move away from each other, right? Now look, what if we go on heating this water? Now you see, more energy are going into the same particles which are already energetic, and they are trying to move away from each other. They are in liquid, they are trying to move away from each other. The more energy the fire puts in those already energetic particles, then the force of attraction between them becomes so less that very soon they actually begin to move away from each other to all over the world. And very soon a time will come where unless you put a lid on the vessel, unless you put a lid on the vessel, the same molecules, that 1 kg ice, 1 kg liquid, water, same 1 kg molecule, they will fly away to all over the world. You cannot trace them. Because the force of attraction between them has become so less that the space between them has increased to almost infinity. So you understand what are the basic difference between these 3 states. Solid. Solid has a fixed shape. Its shape is fixed. And so is volume. Because the force of attraction between the particles are the most in a solid form. And so the space between the particles are the least when the matter is in solid form. In liquid, the force of attraction became less. So the gap, space between the particles have increased. And that's why the liquid, although it has the same volume, but now it has no shape. You need a container to keep the liquid inside it, and it will take the shape of that container. And when in gas, you understand, it has no fixed volume, no fixed shape. Unless you put it lid on the vessel, it will fly away and its volume becomes infinity. And shape is no question of having a shape. Air cannot have any shape. So it has the least force of attraction, almost nil, zero force of attraction between the molecules, particles. And so the space between them becomes increased. Let us put a slide in gist all the points I have discussed till now.
Here we have compared the 3 states of matter, solids, liquids and gases, depending on some fundamental properties. The arrangement of molecules. In solids, the molecules are arranged in a very tightly packed way. In liquids, they are loosely packed. And in gases, they are very loosely packed. In fact, they are not attracted to each other at all. Therefore, the shape of the solid is fixed, but the shape of the liquids and gases are not fixed. Volume, the space occupied, is also fixed in solids. It is also fixed in liquids, but it is not fixed in the case of gases. And one more thing, that solids cannot flow away. But liquids can flow, and gases flow easier than the liquids. Here we must learn 2 new words. When the kinds of substances which do not flow easily and are inflexible, they may be broken down, chopped down, but they cannot be flexed. These things are called rigid. All solid substances are rigid. And the substances that flow easily are called fluids. Like liquids and gases are fluids.
So we will talk about 2 more words now. One is rigid and one is fluid. Rigid and fluid. Actually, rigid means anything that is unbendable. It can be broken down. It can be chopped into small pieces, but it cannot be bent. It cannot be flexed, inflexible. So you see, most of the solids, they are rigid. And what is fluid? Fluid is that can flow. That flows there. The moment you keep it somewhere, it does not stay at the same place, it flows away. So naturally any liquid and gases, they are fluids. Now from one state to another state, we have seen how energy works to change the state of matter. If we give it more energy, more heat, usually in the form of heat, it reaches the next stage. But what happens in the reverse? If we heat ice becomes water. We give more heat to the water, it becomes gas. But what happens if the gas is a little cooled? You have seen it by yourself. That when you are boiling water in a kettle and the gas is going out, water vapor is going out. If you take the lid of the kettle and see inside, you will see some water drops sticking to the bottom side of the lid. Why? Because that lid is a little cooler than the water vapor that is going out as a steam. And when the water vapor touches that lid, it again turns back because it becomes colder. So it turns back to liquid form. And in the same way you have seen how to make ice at home. You get some water and put it in refrigerator. So that you take away the heat from the water. You make it colder, till it becomes solid in form. Let us look at it. Suppose we have the three states: solid, liquid, we add heat and it becomes liquid. We add further heat and it becomes gas. Now what happens that if it is the opposite, we take away heat from the gas, it again becomes liquid, and if we take away heat from the liquid, it becomes solid. These processes have some name in it. I will give you the name and the description. When we heat a solid, add heat to the solid, and it becomes liquid, we call this process melting. And if we go on heating, adding heat to that liquid, it becomes gas. That process we name it vaporization. Now the opposite processes. We take away heat from the gas, we cool down the gas, and it becomes liquid. That process is called condensation. And the fourth process, opposite, reverse process. We cool the liquid so much that it becomes solid again. So we deduct heat from the liquid, take away heat. That process is called freezing. These four stages, four processes of adding heat and taking away heat helps to change the state of the matter. You must have a question in it, and this question is obvious. Because this is a triangle, what about this triangle? Is there any process by which solids, if we add heat to solids, it directly becomes gas without going through the liquid stage? And is there some process also by which we cool down the gas and it does not become liquid but becomes solid directly? Yes, this process is there only for a very few substances. substances like you see naphthalene, like camphor. This process is both processes. Where a solid goes into directly gas state and gas becomes solid directly, both processes are called sublimation. It's a rare, it happens only in a few, very few substances, but it is there. So now let us look at the slides to have all these things understood very clearly.
Understand this picture very well, very carefully. The red arrow shows you adding heat and the blue arrow shows cooling. Solids, on adding heat, it is called melting, it becomes liquid, and liquid on heating becomes gas. And the opposite is that gas cool down becomes condensed, it becomes liquid, and liquid on freezing becomes solids. And the gas to solids are called sublimation. Now let us take it point by point. On heating, a solid substance becomes liquid, and this process is called melting. On heating, a liquid substance becomes gas, and this process is called vaporization. One thing I must make clear here, that liquids sometimes become gas after boiling, and sometimes it becomes gas below the boiling point. It does not boil, but it becomes a gas. When vaporization takes place below the boiling point of the liquid, we call the process evaporation. Like you see here, the liquid first boils and then it becomes gas. But when we are putting the wet clothes under sun, here the water in the clothes, they are not boiling, but they are becoming gas also. They are vaporizing below the boiling point. This particular kind of vaporization is called evaporation. Now next, the reverse process. The process of changing a gas to liquid by cooling it down is called condensation. And the further process of changing a liquid to solid by cooling it down is called freezing. Sometimes a solid on heating directly becomes a gas. It does not become a liquid in the middle. And also a gas, sometimes on cooling down it becomes a solid directly. It does not go through the process of being a liquid. Both these processes of a solid on heating becoming directly a gas and a gas on cooling down becomes a solid directly are called sublimation. But there is one other word also we sometimes used for the sublimation of a gas into a solid. We call this kind of sublimation also deposition.
You may as well learn 2 or 3 new words: solution, solute and solvent. You will learn about them in the upper classes in details. But solution, you know that when 2 liquids or 1 solid in a liquid, they are mixed together. If it is solid, they are dissolved totally. If the liquid, they are uniformly distributed between themselves. We call that solution. Now say you have taken some sugar and put it in a glass of water and then stir it. Suppose in a glass of water you put some sugar in it and with a spoon you stir it well. Very soon you will see that the sugar will disappear and the water becomes sweet. That means the sugar has dissolved and now it's a solution of sugar and water. Now, what is solute? Solute is the thing that has dissolved. Here sugar is the solute And what is solvent? Solvent is that part of a solution in which something is dissolved, in which solute has dissolved. So, water is solvent here. Just as well you learn the term, because in the upper classes you will get more details, you will get prepared till then. In a solution, the thing that become dissolves, that is called solute. And the part that dissolves the solute is called solvent. Right? Let us look at this slide.
It's a very easy activity. You can do it at home. Take a glass of water and mark the level of water by using a paper tape outside the glass. And now add 2 tablespoons of sugar. Stir it very well. Now you see the level of water remains the same even after adding the sugar. Taste this solution, it tastes sweet. So the sugar must be inside the water. What happens is the molecular arrangement in liquids, I told you that they are very loose. They are separate. There is more space between the molecules of water. And the sugar molecules, they entered that space, and so they cannot be seen anymore. They are hidden inside the molecules of water. This kind of situation, when a solid molecules are hidden inside the molecules of a liquid, we call this a solution. Here we call it sugar solution. And some words we also must learn. The substance that dissolves completely in a water or maybe in other liquid is called the soluble substance. Such soluble substances are called solutes, like salt, like sugar. The liquid that dissolves the solute is called the solvent. For example, water, milk. The example we just gave, in that sugar was the solute and water was the solvent. Solutes gets dissolved in solvents to form solution. For example, sugar solution, salt solution, etc.
In the conclusion, so far you have understood, but one more point, a practical point. That is, you see, when we are putting heat, not that always we are trying to change the state of the matter. Because we are going to put heat into some substance, and what it tries to do is that it tries to break away from, the molecules try to break away from each other. First, the substance expands. Expansion. It goes on expanding, and the opposite, when a substance is cooled down, it goes on contracting.
On heating, the size of matter increases, size. This is called expansion. And on cooling down, again, the size of matter decreases. Size of matter decreases. This is called contraction. We make use of these two properties of matter in our daily life.
Not fully changed into the other form. It is only expanding, and not changed fully into the reverse form. It is only contracting. These two stages are often used by us. You have seen the rail lines. They have a little gap between the slabs between them.
Here you see that the two rails are joined by a piece of iron separately. It is screwed down. This is called fish plate that has joined the two rails. Do you notice that there is a space between the two rails? They are not continuous. That's because when the train passes, it becomes heated and gets expanded. So we keep this distance between the two rails.
Because you know that when the train goes over the rails, the iron gets heated. It gets heated so much that it gets expanded a bit. And in the winter time, when it is very cold, that iron becomes a little contracted. We keep this in mind and put a little space between the rectors between the lines. So, if you have understood up to this, let us call it a day now. We'll meet very soon with another chapter. Till then, you stay strong, you stay home, stay safe, stay studious, and also do the homework we will be giving you. Till then, so long, thank you.